something we've talked about, but now the domain and range somehow has changed, right? Because the equation, of course, has changed. So we're trying to get you to move to that next step. How do you get a new domain and range? If you have a new equation, you have to use some prior knowledge. Okay. For example, with tangent, I would hope that some prior knowledge would say that the domain has something to do with the asymptotes. To be honest, that's our goal, is to figure out where the asymptotes are, and you'll have the domain. The range, that might be something that you say, hey, that's always going to be all real numbers, and that's definitely true no matter what's going on with tangent. Now, I'm showing you the two answers. For some of you, that kind of tells you I did it. For some of you, there's a question, wait, why is it not what I wrote? Let's talk about the asymptotes. Okay, and what I'm trying to do here is to approach this without a calculator, which would require us to analyze these numbers. The period, of course, is not equal to 3, but it involves the number 3. Okay, so the period is 60. And then the shift, remember, is not 90, but it involves 90. And of course, it's C over K, so that's 90 over 3. If you were doing this problem completely without a calculator, you would be able to locate a shift point, that went to the left 30 degrees. Okay, so I have a shift point that went to the left, and then we can activate that half the period concept. Half the period is going to be the distance that I need to go from this shift point in either direction so that I can land on an asymptote. Again, that yellow 30 is half the period. It's the distance from the center to an asymptote. And we find out that an asymptote is at 0. It's also at negative 60. But there's kind of enough information at this point to be able to think about the domain. Remember, the domain is always the distance between the asymptotes, which is why you see the number 60 here, the distance between the asymptotes times k plus the first asymptote. If the first asymptote can be 0, then we typically choose that. Now, if you wrote something after this, like plus or minus 60, you'd still get credit. If you wrote plus or minus 60 because you wanted to write down another asymptote, it's fine, but 0 is a little bit better. I wanted to purposely be the voice to kind of go through that, to confirm for some of you and to help fix for some of you, but is there anything different that we can say? Anything that we can add to that? Now, the second equation actually had a new transformation. Did you see it? Okay, did you realize that there was something new about the way that cosine graph changed? Okay, now, if we're just talking domain and range, we still can use some prior knowledge. The domain of a cosine graph is always all real numbers. The range has everything to do with the y values, basically the maximums and minimums. Okay, and if you just look at the graph, you could conclude that it goes as high as 4 and as low as negative 2. Now, like I said, there was a new transformation in here. Did you see it? And we actually want to add this to our notes. There is what we would call a vertical shift. Okay, that +1 that's tagged onto the end of that equation, that's in a new place. And that's a vertical shift of the midline. I didn't necessarily expect that you would have made all these conclusions, but if you think about it, the midline is now up at 1. So that's like a new place because it used to be at the x-axis. And the amplitude of 3 is still based on the distance from the midline. These two purple arrows are trying to show you that the amplitude is always measured from the middle. And we can even make a conclusion here that if you bump up 1 and then you have an amplitude of 3, you would have to be as high as 4. You would have to be as low as negative 2. Okay, because we had here a vertical shift and an amplitude change. Now, on the day where you took some notes about transformations. Maybe you put boxes around them. If you have space, you might want to add this as another box. It's your notes though, so however it helps you to be able to have access to this transformation. As you look at what I have written up here, you can see that a vertical shift is always going to be a number that's added or subtracted at the end of the equation. We'll use the letter D. And so we have basically a vertical shift of the midline. In fact, the letter D is the midline. All right, so we'll add this transformation into our tool belt of knowledge about graphs. As you're finishing up making notes of that, let me give you what we're going to do today. Maybe you kind of saw this coming, but again, it's just the next step in this sequence. Just by the way, this paper will serve as a couple notes, examples, and then it doubles up as something to finish, which you might actually be able to finish while you're in the classroom, but we'll kind of say we'll finish it like a homework. Okay, before we get to that, are there any questions what I'm saying about this vertical shift transformation? Let's talk about the homework. I don't want to forget about that. I know I saw some of you had some questions as you came in. The one I checked looked good. How'd you do with the radian equations? Is there anything that you want to talk about in some more detail? Are you guys okay with number 5? Good. I can. Now, do you have the original sort of specs? Does anybody have the specs for 7? If you don't mind pulling it up, I actually had it, but I realized it's back there on the phone. It's recording, so it'd be a little faster if you pull that up. I'm sure the amplitude was 2. That's pretty easy to see.
The period was 2 pi, that shift is 9.
Yes.
Okay. Okay, obviously the problem's in radians, but that's important. You see pi, you assume radians. That means that you have to kind of adjust your formulas to be in radians. Now, we had a formula that said that the new period was 360 over k. I'm just going to adjust that. Instead of it being 360, we're going to make it 2 pi over k, because essentially 2 pi is equivalent to 360. Now, the new period is 2 pi. So this circled 2 pi, I'm going to plug in right here for the new period. Although some of you might be saying, but it's the same period. Just going through so you can see, that's why k equals 1. Okay, so I'll put the number 1 in for k. I don't have to put in like some kind of pi for k. I already took care of the pi by working out the formula. And then the shift, of course, is equal to c over k. There's nothing here that you need to like change to radians, okay, because the letter c is going to kind of work itself out based on how I solve this. Okay, so it looks like c equals pi. When the problem's in radians, you just have to adjust your period formula, okay, because that's the formula that uses a radian number. Does that help out? Anything else? Okay, you guys, you seem to be at the right place. Okay, each day we're adding something. Honestly, that pipe cleaner activity that you're to look at as a hybrid activity will take all of this and put it together, which is exactly the spot that we'll be at tomorrow. But for today, what we want to do is we want to be able to look at some graphs, as you can, I'm sure, tell from the handout. We want to look at some graphs and see if we can write the equations. Okay, now it's kind of one of those things where, depending on the student, you might pick up on this a little faster. You might be at a different place. If you can work ahead, just so you know, I'm going to go through the first 3. I'm going to go through the first 3, and most students do listen because there's something in each of these that is worth repeating. And you're probably going to feel like that at some point you're ready to kind of run off on your own, and don't let me hold you back. Okay? When I give you a graph, one of the main things you need to realize is that I'm not trying to trick you. All shifts and periods will be in some multiple of 30, 60, 45, or 90. In other words, common angles. So all shifts and periods will be in some sort of type of 30, 60, 45, or 90 sort of multiple. Okay, and that's actually where this problem, well, it depends on where you want to start the problem. Actually, it might be worth noting for this first sine wave here that it clearly has a new amplitude. Depends on how much you want to mark it up, but it's definitely the case that from the midline to the maximum minimum that we are going up or down by 3. So the amplitude is definitely 3, and that's usually a little bit easier for kids to see, but it's worth repeating that has transformed. It's usually the shift and the period that require the most attention. And so let's talk about that. You actually want to start with the shift. And for a sine wave, you have to be aware of the original y-intercept. Now, the original y-intercept of a sine wave is always, as it was on the first day, it is the origin. Okay, so that's our shift point right there. And what we're basically asking ourselves is, where did the y-intercept go? Where could it be? So where did the y-intercept go? Where could it be? You should be right here. Okay, now that point right there is the shift point because the graph proceeds upward and onward from that spot, which is exactly what the original y-intercept does. And so now we just need to determine that value. So you kind of look at it and you say, does it look like it's 30, 45, 60? It's not 90. Now, you shouldn't say that it's 45 because 45 would look like it's right in the middle. And so therefore, the only thing it could be is 30. It's shifted 30 degrees to the right. Okay, so we have our shift. Now, if you're saying that's kind of backwards, well, yeah, you want to think about the shift first so that now we have a point that we can use to help get the period. Now the period is going to be one cycle, and I'm going to trace for you one cycle because I want to make sure that you realize that it has to have a full positive and a full negative, and then we get back to where we started, which again, we have to think about the value of that point. Okay, now that little point right there is right past 180. 180 is the hash mark that's right beside it. It's only 30 degrees past 180, and that's why we can conclude it's at 210. Okay, so we have a period of 180. We have a period of 180, which of course is just the distance between those 2 points. Okay, and then you're kind of back to doing the stuff that we did last week. You guys did a nice job. The homework looked good, but don't forget that you still have to find the K value. The K value is actually going to be 180 when 180 equals 360 over K, which is a pretty common K value of 2. And then, of course, you have to find the C value. Remember that the shift of 30 is equal to C, in this case, over 2. So C equals 60. Now be careful. This is the part of that I warned you about last week, that that you still plug these numbers into these formulas. And that's why we can get K equals 2 and C equals 60. Okay, be careful about, of course, using too many shortcuts. But don't forget to write your equation. And your equation still has to be of that sine template. So make sure you have sine, make sure you have x, and we get 3 sine of 2x minus 60. Please, if there's something that happened that you're wondering how I got it or I went too fast, just give a holler. I realize that people pick up on this differently, but each of these problems has something worth repeating. I'm moving on to the tangent problem. Maybe you're kind of doing some stuff on your own. That's fine. There is no amplitude for tangents. You don't have to worry about like trying to figure out that number. You should be thinking about the shift. Oh, where did the y-intercept go? Oh, where could it be? Of course, now that we've been talking about tangent for just about a week, I would expect that you feel pretty comfortable that the y-intercept for tangent is right there. Okay, so that point looks like it has moved either here or here. Okay, this is an example of a problem where you could have an equal argument that is shifted to the left or the right by the same amount. Okay, so when it comes down to writing our final answer, you could use a plus or minus. Okay, now if you didn't use a plus or minus, you would still be right, but just saying, we have an equal argument that we went left or right 45 degrees. Both of those points could satisfy the shift. Okay, the nice thing is that those 2 points also provide us with a period. If you just find the distance between those 2 points, you now know that the period is 90. I did not get the asymptotes involved because I don't see the asymptotes, and it sometimes can make the problem tricky. So again, we don't need the asymptotes to be able to come up with this answer. And that's kind of my message to you, so that you can come up with an equation and get moving on. Okay, now remember, you still have to take these 2 numbers, that is 90, and you have to use it to solve for your C value, your K value. But as long as you use 180 over K, you'll see K equals 2. And then you want to solve the 45 also for your C value. Okay, and you'll get C equals 90. When you write your final answer, as we said, you could use a plus or minus, but as long as you had one of them, you would be right. Please do not say plus or minus 45, but make sure you're saying plus or minus 90, as that is the C value. Again, is there anything that happened there that we could elaborate on? Okay, the neat thing about the place that we're at today, being able to look at a graph, is it gets us one step closer to an application. I'm telling you that this chapter gets real interesting when we finally apply all of this. There's all kinds of applications of these types of graphs. That's coming, okay? But right now we're just kind of looking at a basic graph. And so we arrive at this last one, this cosine. Now this, again, it might be worth just kind of listening for a few moments. Sometimes students' eyes will sort of notice that the max and minimums maybe are at, well, not maybe, but they're at 3 and 1. Sometimes students' eyes will notice that the midline is at a new place. Do you see how all these numbers kind of relate to each other? We have to notice that the midline is at 2. We have to notice that the max and mins are at 1 and 3 so that we can get the amplitude. Now remember, the amplitude is the distance from the midline to a max or min. So it's actually still 1. The amplitude is still 1. That's clearly the distance from 2 to 3 or 2 to 1. Shift. Oh, where did the y-intercept go? Oh, where could it be? Actually, do you have an answer to that? Someone from the gallery? Oh, where did the y-intercept go? Or where could it be? Were you thinking it didn't go anywhere? If you were thinking that, you are correct. Because when we ask about the shift, we're talking about a horizontal shift. Folks, that point right there did not move horizontally. Now, if you're saying, yeah, but it moved vertically. It did move vertically, okay? But the midline will take care of the vertical shift. When I ask you where the y-intercept went, I'm asking you if the y-intercept moved horizontally, and it did not. Okay, so there's no horizontal shift. There's no horizontal shift. But as we said, there is a vertical shift. And we could have said that a few moments ago when we noticed that the midline, of course, was up 2. Now, cosine starts at a different point. Okay, but since we've located that point, we might as well locate a point that represents an end of the period, which could be this other red dot, and that will be one full period to trace it so you can see it from point to point. And of course, that distance is 180. Now we know it's 180 because we're using some of the hash marks here to help us. This hash mark right here is at 180, which it's always been. Okay, so the distance from point to point is the period, and I'll just put it underneath here of 180. Okay, make sure that that period of 180 helps you to get the k value of 2, and that's why we're going to see a 2x right here. There is no horizontal shift, so I don't have another number inside, but we did have a vertical shift up 2, so we'll put a plus 2 at the end of the equation. The amplitude is 1 if you want to write the number 1 in front, or just leave that as assumed. So we end up with cosine of 2x plus 2. Cosine of 2x plus 2. Purposely, there's a little bit of time here that I would imagine you'll want to see if you can figure out the next one. And honestly, depending on how quickly you catch on, you can figure out as many of these as you want. Put this in like a regular homework category. It's not due till Thursday, so you don't need to upload it. Okay, you don't need to upload or do anything like that. just have it for Thursday. And again, tomorrow we'll take a little pause and you'll have that online activity.